Hey everyone, welcome to Dr. Frank's Finance World. I am Dr. Frank the Bank, where I try to teach you something about finance that hopefully you can make a little bit more money on out there in the future. Please be sure to subscribe and hit us up with notifications out there so that we can send you new recordings as they come due along the way. And we always try to update the notes for new websites and so forth. The third part of this risk and return is used in the portfolio side of finance, and it's how you would think about forming stock portfolios. And so in that case, the required return of a portfolio is the weighted average of each of the stock's required returns. So in this case, if you put half of your money into the return for high tech, and then we actually had a return for collections of 0.5%, didn't do much making money there, but you put half your money there, you would end up with a total return. 0.5 times 9.5 plus 0.5 times 0.5 gets you an actual return of 5%, and that therefore the expected portfolio return would be 5%. But all you are doing is taking the weighting, how much money you put in each, and multiply it across so you can see what your actual return would be. Works in a lot of other things in life as well. So let's look at a portfolio problem that puts it all together for us here. So ultimately, we have the different probabilities, and we have a couple of different stocks, stock A and stock B. And these are the returns for stock A and B, given these different probabilities, economies, or whatever's going on out there. So you can see they kind of move opposite of each other to some degree, down versus up and all the rest. But, first step first, what are you going to need to do to calculate a problem like this? You can actually know that because this all adds up to 1, this one is 0.4%. That's a pretty common one that I put on tests that I make students figure out. But the probabilities always have to add to 1. But I really want you to focus on creating a portfolio. That's really the key to these problems, is creating a portfolio based on the weighting that you would put in each one. So if we said it for the first portfolio we're looking at here, that we were looking at a weighting of 50% in each, we'd be taking half of A's return and adding it to half of B's for this event, a good economy, bad economy, whatever. Half of the A's plus half of B's, half of A's plus half of B's. And that's exactly what we did down here. If you take 50% of the 20%, you have a positive 10%. This is negative, so it's a negative 5.5. So when you have positive 10 minus 5.5, you have a probability, or a payoff, if you will, a return of 4.5%. If you took half of 10, you have 5. Half of 5, you have 2.5. This one is 7.5%. And these are the component values over here. These are not the actual observations. We'll get to that in a second. And then multiply across down here, and you have 7%. And then what I would recommend you do is redo it with only portfolio A and B. Now the neat thing is you can multiply across, and you can actually add down over here to come up with what the values are and to come up with your expected return. So how does that look? If you multiply 0.5 times 4.5, you have 2.25%. And if you take 0.1 of 7.5%, you have 0.75. And then you have 0.4 of 7%, you have 2.8. When you take those together and you add them up, you now have an expected return of this portfolio of 5.8%. To find the standard deviation, use exactly the same equation we were looking at before, which is the sum of the actual minus expected squared times how often it occurs, the probabilities. So in this case, we had 4.5 was the actual, subtracted the expected of 5.8, we squared it, and that occurred 50% of the time. The next one was we had 7.5% minus 5.8 squared times 0.1, 7% minus 5.8 squared times 0.2. We've gotten all of these actual observations over here. We end up with these different outcomes. So when you multiply it by the probability, you now have 0.5 times this gives you 0.845%, 0.2 times this gives you 0.289%, and 0.4 times this 1.936%. When you add them all together, you end up with a variance of 3.7%. But remember, the standard deviation is the square root of the variance. So when we take the square root of it, we actually get a standard deviation of 1.752%. So that's how you'll actually do the portfolio problems that you'll see, and it's how you figure out actually mathematically when you get deeper into investments. There's a way of looking at inside of Excel to figure out what is the best payoff, what's the best way to put these portfolios together to have the best return and the smallest standard deviation. So keep in mind that finance is a process. Many times I think it's a three-step process, but apply the weighting to create a portfolio of returns in these type of processes. Very important. Find the expected returns by the probability times the outcome, and then find the variance by the actual minus expected squared times its probability. Take the square root of the variance, you have the standard deviation. So hardest part, honestly, is you must get past the math. I try to tell you that it's a process up here so you understand that it may be prisoner to the math, but ultimately if you understand a process like this stuff right here, you are going to be way better off when it comes to doing problems out there. Practice it as a process. So be sure to send comments to me down here if you have any. Dr. Frank's Finance World or F. Smith at JBA Wealth. Appreciate you taking the time. Part 4 of this, we'll be doing a bunch of problems, and hopefully you can look at those and it'll make more sense to you. So have a great day. Appreciate you. Bye-bye.